In this video, we'll create internal grooving and tapping toolpaths. After completing this step, you'll be able to create a single groove and tap a hole. In Fusion 360, we want to carry on with our CAD/CAM lathe dataset. The last operation we have is an internal boring toolpath, and this is going to allow us to get in and cut the internal groove. Before we go much further, I'm going to go to Inspect and Section Analysis and create a new section analysis based on one of the default origins. I'm going to use the XZ plane and say OK. This helps us look inside the part and makes the selection process a little bit easier. Now we're going to go to Turning, and we want to select Single Groove. We need to select an appropriate tool, so we'll go to our Introduction to CAD/CAM Lathe dataset and select ID Grooving. Once we select it, we'll need to make sure that the mode and direction is set to Inside Grooving. Next, we're going to go to our Geometry section and grab the back edge of the internal groove. We then want to change the groove alignment to back, and we want to move on to our radii. I want to make sure that the tool knows exactly how much material has been removed and how much material is left inside. So for my retract plane, it's set to clearance, and my clearance plane is based on the stock ID minus 10 millimeters. Instead, I'm going to use a selection. I'm going to grab the inside diameter. This gives us a little bit more clearance. And you notice that this is set to minus 10 millimeters right now. If we set it to 0, notice that it's still displaying as red. When it's displayed as red, it's telling us that the clearance radius must be below the inner radius. The inner radius right now is defined as the stock ID, which was 0. So once again, we'll use the selection, and then the clearance value, we can use that minus 10 millimeters, which gives us a little bit more room. For our passes, we have a couple options here, but I'm going to create the toolpath first, and then we'll explore some of the options. Let's go ahead and say OK, and let's minimize the models in our browser and note that our tool is displayed as red. The preview is showing that we're removing too much material because the size of the tool is just too large for what we need. So let's go ahead and right-click and edit the tool. The first thing I want to do is redefine my insert. We're going to be using the same insert type, so the shape is square and the tolerance and the cross-section are the same. However, we need to modify some of the values. For the overall length, we're going to set this at 8 millimeters. The width of our tool is going to be 2.3. And the corner radius is going to be custom, and it's going to be set to 0. The head length, in this case, we can leave at 3.75, and the groove width is going to be 2.7. Next, we want to move to our holder setup. This is going to be a right-handed holder as we're spinning the spindle in the same direction for all of our toolpaths. This is an important distinction. Now, obviously, you can have the spindle change directions, but if you want to continue to have it spinning while you're making your tool changes, it's important for us to just be aware of the orientation of our tools and the direction the spindle will be going. For our cutting width, we need to make some adjustments. The cut width is going to be 8 millimeters. Our head length is going to be reduced to 15 millimeters. The overall length is going to be reduced to 75 millimeters, and the shank width is going to be reduced to 5 millimeters. In the setup, note that we are spinning in the clockwise direction, and we'll go ahead and accept. It changes the orientation of the tool, but now we need to select the toolpath and regenerate. Once we regenerate, we're able to see the cut on the inside of the part and the material that's been removed. Now that we've removed the material, we can create our internal tapping operation. We're going to go to Drilling, select Drill, and then we need to select the appropriate tool. We're going to go to our Fusion 360 library, and we need to look for a tap. So from the filters, we're going to take a look at the options that we have. Tap right hand, and then we can select a specific diameter. If I enter a value of 25, note that nothing comes up. If I enter a smaller value, such as 20 millimeters, you can see here that we have a few options. I'm going to select a range and go from 20 to 25 and see if we have anything larger. Note that we have a 24 or an M24 by 2.0. We're going to select this even though it's not the right tool, and we'll have to make some adjustments. In the geometry section, I'm going to select the area in which we want to tap. And then in the height section, we're going to go to a front view and note that it's going to be going to the whole bottom based on our selection. If we want to have an offset, we can enter a negative value. In this case, I'm going to enter a -2 millimeters, and that'll let the tool go a little bit farther. The next thing that we want to do is we want to modify our tool to be the right size. In this case, let's expand this and let's right-click and edit our tool. First, I'm going to go to the post processor and adjust this to be tool number 11, and I'm going to disable live tool. I need to synchronize the tool motion in the spindle direction. So it's important that the spindle direction and speed is coming from the spindle on the machine and not any live tooling in this case. Next, we're going to take a look at the cutter definition. Right now, the diameter is set to 24, and we're going to increase that to 25. We can leave the shaft diameter at 22, and all the rest of the parameters are fine. Noting that the thread pitch is set to 2, which is the same because we're using an M25 by 2.0. We're going to accept the change, and we need to select and regenerate the toolpath. Now we've updated this based on our new tool. At this point, let's make sure that we minimize our toolpaths, and let's save the design before moving on to the next step.